Hello everyone, this video is to document openly and with transparency my first cold moonlight test. This test occurred on the 7th of May in Northern Virginia, and I'm going to take a little bit of a move out of Sly Sparkane's playbook and use PowerPoint so I can walk through and talk through all of these rather than have a purely curated video. So, a little bit before moon up, I packed up all of my equipment and I drove over to a nearby elementary school. It's pretty near to my house. This is the setup that I had. You can see the computer on the left. That way I could monitor the data that was coming in. The wires that you see attached to the back of the telescope, those are the thermal sensors that were provided by Where's Wally. And those were originally sent to me by Wally from Australia as part of my Cavendish experiment. And again, he graciously just told me to keep them, that maybe someday I would use them. And here I am using them again. So Wally, thank you so much. As you look at the telescope, you can see the Schmidt-Cassegrain telescope, and I've got 3 wooden dowels attached to it. That way I can mount a piece of cardboard off of the back of it. That cardboard is parallel to the mirror surface on the back of the scope. And that is kind of the purpose to this video, is to concentrate the moonlight and have a parallel plane where all my sensors are mounted to. As I said, when I set up, the moon had not quite crested yet, but the scope was tracking. I verified that as it peeked in through the trees just to make sure that way I'm actually tracking the moon as it's coming up. And here's another shot. At this point, this was later on in the evening. The scope is open, so this was not during the initial test run. So this is the setup for the sensors. The bottom sensor is in concentrated moonlight. The second sensor is in the direct shade of the telescope itself. The top sensor is in direct moonlight. I also have a fourth sensor that is off scope, taking ambient temperature. It's about 4 or 5 feet away from this. So I have 4 different temperature readings. One thing I realized as this was initially getting set up was that when the moon does crest, that third sensor here is going to be in direct moonlight, even though the first data I wanted to collect was no moonlight data. So the cover is on the scope here. So to correct for that and to block out the moonlight for that third sensor, I literally ripped off the back of my notebook cover and mounted it to the front of the telescope. And you can see there that that sensor is now in the shadow, and as well the cover is on the telescope. And once it came time for the experiment to actually begin, I removed both of those and started collecting data after it had a time to settle from the impact of the moonlight. So I'll walk through now kind of the timeline of events. On this night, we are almost at 100% illumination. At 2112 is when I got the sensors powered up. 2120, mounted the sensors, but no moonlight was visible. It was pointing at the moon through the trees. Now, a couple minutes later, about 20 minutes later, you see reset, froze. I was having some issues with the sensors. The Arduino was freezing up. The issue I was having was internet connectivity, because I was using my phone as a hotspot, and that's what they were transmitting to, as well as my laptop. That's how I was receiving and reviewing the data. Then at 2158, covered the telescope. Everything is set up. So the moon had not come up yet, but that was about the time it was going to. A little bit after that, I did a thermometer test, and at the end of this video, I'm going to post all of the videos that I took that night. I'm not going to walk through them. They're each between 1 and 3 minutes. So if you want to watch all of them, the timestamps for when those videos were taken will be on the videos, but all of those videos will be there for the IR sensor and for the IR thermometer, as well as the FLIR. So whereas Wally froze again, 2225 took a FLIR reading, and here's where you can see I started documenting the FLIR readings. There is a difference between the FLIR and the IR. I'm not going to get into that today. Differences in how they measure, I need to do some research onto that. Maybe somebody who's more of an expert in it than me can let me know. But you can see the differences in the 4 different sensors. Now at 2259, I moved the open air sensor directly above the sidewalk, because if you look at how this was positioned, you can see the telescope was on the sidewalk, so I wanted that open air sensor directly above the sidewalk as well. So that's when that moved over. At about 2230, I moved the board closer to the back of the telescope. The reason I documented that is because that is now decreasing the area between the cardboard and the back of the scope that could increase any type of thermal radiation back and forth, the heating causing by that. Then at 23:35, took another FLIR reading, and then took another IR reading. And then 2237 is when I placed the moon block on the open air, mounted the cardboard to the front. So there was a little bit of time while it could have been receiving Moonlight, but I let it sit for another hour before I actually started collecting data for the open Moonlight. So then at 2339, I opened up the scope, and that's when I took the front cover off and took off the cardboard as well that was blocking the third sensor. And what is absolutely amazing with this is with an eyepiece removed from the back of the Schmidt-Cassegrain telescope, you can actually see the moon itself. And you can focus it in, because the rear mirror on the Schmidt-Cassegrain is where the focusing comes in, not on the eyepiece. And you can actually see the details of the moon as it's falling upon, the light is falling upon that cardboard. And the telescope from this point sat for 1 hour. Did nothing with it other than verifying that the telescope kept tracking. Every once in a while I had to move it to make sure that the sensor was still in the moon. It never left the moon. I just kept moving it as it adjusted a little bit to keep it centered on it. It sat like that for 1 full hour. And then at the end of that time, well past midnight, is when I did another IR test and another FLIR test. And you can see the results right there. I'm not going into the results today. That's not the purpose of this video. This video is just to show everyone what I did that night. Once all this testing is done, we will move on into more formal findings of how everything happened. So I only got 1 hour of data collection that night, and that is the results of it. Now, to talk about the thermal sensors. So these are a snippet of the readings from that night, from those thermal sensors. You can analyze this data if you want to. You can see it, and this is early on in the evening, so this was not when the moonlight was a factor. But the reason I'm showing you this is that I'm doing some corrections with this with the assistance of AB Science. And the reason that we're doing these corrections is because these sensors are not calibrated. So if you look at these, this was a test that we did. I had all 4 sensors coupled together. They were side by side, and you can see that they are not the same. They have variance between the two. Column A is generally a little bit lower than column B. Column C is also generally a little bit lower than column B. So we are taking data to calibrate for that. So these numbers are not exactly accurate for a calibrated purpose. In the end, that's what's going to happen. If anybody wants this data, I will gladly give it. You can have the calibration readings. You can have the full readings from that night. Again, the purpose of this video is not necessarily to discuss results. It's just to talk about methodology. So now the way ahead for this experiment, what I'm going to do is I'm going to repeat this several more times over the summer. It's going to be at varying times. I had planned on doing a new moon test this weekend, but due to weather and occupational reasons, I've got to leave town this weekend. Possibly a video on that someday soon. I'm not going to be able to do the new moon test this weekend, but there will be a new moon test. And that new moon test will be pointing the telescope at the exact point in the sky where I was looking at for the full moon. We'll also probably do quarter moons, and we're also going to do some other types of testing. One of the things that we're going to test, and this is thanks to some insight and thoughts by Bob, I'm going to take a piece of the plexiglass from the Cavendish, and I'm going to mount it parallel to the back of the mirror. It's going to be mounted directly to the back of the scope, all the way up, and blocking that third sensor. And the purpose for that is to create the functional equivalent of the air gap between the cardboard and the back of the scope. That way, if radiative heating is the cause of this, then maybe that would also show the results of that. If we use that plexiglass and those then sensor C and sensor A are the same, then maybe it's radiative heating that's causing it. And then I'm also going to do some more experimentations with wood backing, with rubber backing, and with plastic backing. So over the summer, as this continues, I'll be running this experiment many, many more times. I may or may not do a video after each one. It just kind of depends on the results and how entertaining or interesting that particular video would be. So at the end of the summer, there is going to be a larger video to encompass all of the data that was collected. That's going to also include the results of all of the thermal sensors. And that's after AB Science and anybody else who wants to lend a hand and assist with the calibrations that need to be done for those sensors. And those calibrations will also be public. That way, if anybody wants to say that there's something sneaky going on as to why we're adjusting those numbers, you'll have the information as well. So it's going to be complete transparency. There's going to be nothing hidden from anyone. At any time, if anyone wants any of the results, if anyone wants original videos, if anyone wants original photos, hit me up, let me know. I'll throw them into a Google Drive or into a Dropbox, and I will give everything freely. So if anybody's got any more insight, thoughts of how to adjust, improve, make it more accurate, I'm always open to suggestion. And I want to thank everybody who has already given assistance in the thought process and the build and the different abilities of this test. Just like the Cavendish, a large majority of this test is because of the input that I've gotten from the community. So thank you everyone very much. Please keep that input and that assistance coming. And with that, here are the videos. Uncut, original, for everyone to enjoy. All right, I'm doing a test with the laser thermometer. Right now, the moon has not crested the trees yet. The telescope is covered. I've already confirmed that that sensor in the middle is in the middle of where the moon will be coming through. That sensor is going to be in the shade. That sensor is going to be in the direct moonlight. And then I have another sensor mounted that fell down that I will now move back up. Need a little more tape. But we're going to test here. Do this. Right next to that sensor, 52.4, 51.8, 51.7, 51.9, 52. 51.9, 51.6, and 50. And to confirm, the telescope is covered. Moon has not crested the trees yet. The only light that is shining upon that right now is the street lamps. You can't see it right now, but the moon is, I think, right about there. It's behind a cloud. Or is it right about, actually no, there. Right about there behind a cloud. Just coming up over the trees. Currently the scope has the cover on. There has been no direct moonlight exposed to the sensors. Concentrated area. Shade area. And then that which is not directly behind the telescope. So if you go all the way around the scope, you can see they're definitely hotter on the lower side of this, even this bottom half down here. All right, it is about 11:30 or so. Quick shot of the moon. for the last hour or plus. Scope has been covered. About an hour ago, I put this shield up to block the direct exposure temp sensor so that the moon was not hitting or falling on it. Let's check the ground. We've dropped a couple degrees. Go around the pad. Similar to before, the higher you get off the ground, the lower this backstop is. Alright. Trying to get my bearings so I hit the right spot. Is that? Oh. Never mind, that's the scope itself. So that's part of the scope. So what we need is this is tricky. There we go. Cardboard right off the tip of that sensor. That is the one that will be in the concentrated Moonlight. That is the sensor that will be in the shade. And then up top, sensor that will be in the direct Moonlight. Alright, it's about 11:30. The telescope has still been covered up. I added this about an hour, a little over an hour ago, to prevent that sensor from getting hit by direct Moonlight, so that has not been in the direct Moonlight, even though the front has been covered. So we will check with the IR. So just to verify that, the spot that will be in the direct Moonlight, 10.8. Shade, 10.7. And that will be in the direct Moonlight, 9.8. Alright, time to take the cover off. It is currently about 12:40 a.m. Gonna take last temp measurements before we pack up for the night. Concentrated Moonlight. Shade from the Moonlight. Direct Moonlight. And the ground. I'll do them all again. Concentrated Moonlight. Shade. direct, and the ground. It is about 12:40 a.m. Taking my last measurements before packing up for the night. Ground temp. You can see the moonlight there. Do them all again. Ground. Moon. Shade. And direct.